I would like to introduce you to a project that I've been working on for the past couple of years, which is called Machina. And it's a framework of tools uh, that hope to streamline the way we control a mechanical actuator, the way we control robots, and the way we think about how we tell them what to do. It's trying to streamline communication between humans, computers, and then machines. And it comes from the motivation behind the project is that when we want to program machines to do things, we do have engineering tools that are really good and really precise and really efficient in creating this, but they have an insane entry barrier to learning and mastering them. So, for example, this that you're seeing here would be a typical program written in Rapid Code, which is the language that runs inside ABB robots. And in order to write this program, you need to know a significant deal of spatial transformations, forward kinematics, inverse kinematics, spatial rotations. It's kind of not something straightforward, which means that in the engineering field, it's a really good tool because it's precise and it's efficient. But for people, perhaps in the more creative fields, who want to start tinkering and working with robots right away without the expense of really learning what's going on behind the scenes, it's a significant entry barrier. So I was hoping to tackle this problem a little bit and then set myself to create this set of tools, which I call action-based programming. And what I mean with that is that it's heavily influenced by some of the ideas that were developed in the early 70s by Seymour Papert and Turtle Graphics and the Logo language, in which with a very simple set of instructions that were dependent on the state of a particular cursor, in this case the turtle, you could command the turtle, the physical device, to move around in space and to perform actions with very simple numerical inputs and very simple instructions that were human relatable, right? So the main API of Machina looks something like this, but this is this is evolving very rapidly, so this version is actually pretty obsolete. If you want to go to the latest version, you should probably check this link here. But one of the motivations behind Machina is something that looks so complicated and so unintelligible for humans as this code is. Written in Machina, it would look something like this. Whereas, even if you have never used robots or written any robot code, even reading through this program, it's a bit more intuitive and a bit more clear than it would be to try to decipher what the previous Rapid program that we saw is. So some of the features of Machina is that, for example, most of the actions that you can tell the robot what to do, they have an absolute form, which is this one. So move to a certain point, or rotate to a certain orientation, or set the speed to a certain value, right? Whereas they also do have a relative version, which is wherever you were before, move so much distance in the x direction, or wherever you were before, rotate 90 degrees around the axis, and however fast you were going, increase or decrease that value by a particular number. So absolute actions have an effect that doesn't depend on where the robot was before, because they set a completely new value to that parameter, whereas relative actions depend on the previous state of where the robot was. Depending on what you're setting yourself to do, very often absolute actions will be very useful, but also, especially for real-time and for interactive interaction, relative actions are very handy. So for example, if you're setting yourself to create some form of 3D printing, then you probably generate your toolpaths in some visual programming language or CAD software, and for that you have the coordinates of all the points, so absolute motion is probably more convenient for you. Whereas if what you want to do is to move the robot around in real time, so for example, just move it a little bit to the left or the right, more in like an interactive way, then probably relative actions are going to be much more handy in this case. Another interesting feature of Machina is that it can work in multiple coordinate systems, so you can relate all the actions to the world coordinate system, which is usually at the base of a robot, or to the local coordinate system of the tip of the robot, very often referred to as the TCP, the tool center point, right? And any other arbitrary plane that you can define as well. But more than that, one of the main strengths of Machina is that it's not only useful for generating offline programs, meaning just creating, designing a program and a set of actions, and then compiling and exporting whichever native code for that particular platform would be, but to work in real-time mode, meaning have a live connection between the computer, the controller, and the physical robot device, and stream actions in real time as they start happening. So one of the interesting things is that because Machina is an unified language, anything written in Machina can be compiled to, for example, this is ABB, this is rapid code for ABB robots. This would be UR script for universal robots. This would be KUKA PRC for KUKA languages, for KUKA robots, and even it can be exported to a human readable version of that program, which you can line by line read very easily. There are tools that help with this offline creation of programs. So for example, there's a Machina for Dynamo, BIM, the visual programming language for Dynamo and for Revit. There's also a Machina for Grasshopper, the visual programming language for Rhino, and both are very handy for creating programs that are composed of sets of actions and then being able to compile them to whichever native language, like rapid code, UR script, you name it. But more than that, there is also the real-time part. So for example, here in this example that we're watching, I have a table with that is responsive to certain trackers. So I can create a stroke on the table, and then I can stream that stroke to the robot, and the robot can follow that path, therefore creating this form of like virtual drawing table of sorts. I can also work interactively. So this, what we're seeing here, is a C# REPL, so a kind of terminal that has Machina loaded in the back end. And what we can see is that I'm typing instructions in the terminal, and in real time those instructions are being streamed to the robot, and the robot is following them and then waiting for new instructions to come. With these kind of tools, then it becomes really easy to create interactive installations where, for example, in this one, there is a computer vision system that is tracking the motion of my hand and is making the robot follow that motion in real time. Or in this example that we're seeing here, where there is a commercial Xbox controller that has been connected to a Machina framework running on C#, and that is controlling in real time the movement of this robot. Furthermore, one of the interesting aspects of Machina is that its architecture, so from the public API, the set of instructions that you can use, and all the internal classes and all the internal functions, they're all platform agnostic, which means that all of these can be created without caring about what device you are compiling to or which robot you are connected to. But then by subsetting, by extending a particular subset of classes, particularly to the device that you're targeting, then all these actions and all these instructions can be compiled to a particular machine. So right now, Machina works for ABB robots and universal robots in real time as of the recording of this video, but it could be extended to any other machine that moves in 3D space, like KUKAs, 3D printers, laser cutters. It actually works for 3D printers too. Drones, you name it. So there's a lot of work in progress in this. So if you're welcome to check all the tools that are available in Machina in the main GitHub repo, and but you're also welcome to check some other videos where I explain a bit more in depth some of the tools that you can find in Machina. I forgot to say, all the projects in Machina are open source, so you can also check the code that's underlying these tools and then use it for your own benefits. Thank you very much.